Okay guys, you're welcome to our class today. And in this class, we are going to be determining the density of an irregular object using an overflow can or an Eureka can. To achieve this experiment, I'm going to be using a chemical balance, and here is an Eureka can or an overflow can. Here is an empty beaker, and here is a measuring cylinder, and of course a beaker containing water. Here is our irregular object. Now the essence of the rope on it is just to help to avoid spillage when inserting into the overflow can. Now recall that to deduce the density of an object, we use the formula density is equal to mass per unit volume. Now, it is easier to use the measurement and calculation of this particular formula in deducing the density of a regular object like this. Taking a look at this wooden block, you would notice that it is cuboidal in shape, meaning that if I intend to deduce the density of this particular shape, which is regular, all I'll just have to do is to use the formula length times breadth times height to deduce the volume of this particular cuboid, and then weigh it here and then find the mass. Here the mass is 240.7, which would amount to 0.241 approximately in kg. So by the time I measure and then calculate, I can be able to deduce the density of this regular solid. But that is not the case for an irregular solid. I am going to apply the principle, the Archimedes principle, in deducing the volume of this particular irregular solid. And of course, I will measure the mass of this irregular solid using the chemical balance here, and then we'll now deduce the density in the end. So to start with, I'm going to deduce the mass. So I'm dropping this on top of the chemical balance, and the mass in grams is 39.8. So I'll take note, okay, 39.9. The mass is in grams. So I'm going to eventually convert this to kg before I could be able to get my answer correctly in kg per meter cube. So I'll take note of this value, 39.9, and then proceed. Now, having taken note of that, I will now proceed to pour in water into the overflow can. Here is my overflow can. So I'll pour water to the point of overflow, which is going to be collected from using the empty beaker. So here, I'm dropping water into the overflow can. All right. So is overflowing, so I would wait for it to finish dropping. So the implication of this is that the water level, as you can see from here, has gotten to the point of overflow. So any other material that is being dropped into this water will bring about an overflow. And from Archimedes' principle, you know that the volume of liquid that is being displaced is equal to the volume of the object when it is submerged into a liquid. So I'm simply going to now remove this one. Since I've collected the extra water, I'm going to remove it and then put in my measuring cylinder. So here, my measuring cylinder to help me get the volume of the liquid that is being displaced. So I'm now going to drop the irregular object into the Eureka can. So I like that you observe what is going to happen. I'm going to just simply do that carefully. Drop the irregular object into the overflow can. You can see there is an overflow. So it's gently dropped. So I'll wait for it to finish dropping. It's still dropping. All these small drops can affect your readings. So you can see as it's dropping. Okay, still dropping. Okay, just be patient while the drop finishes, because it's important that we collect all the water, because these small drops can affect the volume. even if it's by 0.1 mil. It's something. So as you can see now, I think that the drop is becoming a little bit slow. So we can now proceed. So to proceed, we are going to read at eye level the value that you can see from the measuring cylinder. Yes. So if you read it at eye level properly, you're going to see that I have here that the volume in milliliters is what? 17 milliliters. 17, as you can see it here. So here is our conclusion from what we had deduced earlier, which is the mass of the irregular solids to be 39.9 grams, which is equivalent to 0.0399 kg. And then from the practical that we conducted, where the volume of the liquid which is displaced by the irregular solid gave us 17 mil. By simple conversion into meter cube, we got the value 1.7 times 10 raised to the power of minus 5 meter cube. So to finally deduce the density of the irregular solid, using the formula mass over volume, substituting the values and calculating such, we got that the density of this our solid is 2,347.1 kilogram per meter cube. So I believe that this has really been of help to you. Always do subscribe and like the videos, as more will be coming. We so much appreciate. Thank you very much.